Okay, students, good morning to one and all. Good morning. Uh, we'll,
Hello.
Good morning. We'll start the session now. Yeah, see here, it is a three-phase, it's 100 kilometers length of the line. In yesterday's problem, we have dealt with for the same problem, how to find the nominal T network model and nominal pi method. We have calculated the efficiency and regulation of for a given data. Here we have to calculate, we are concentrating here in the nominal pi methods. This is the nominal pi method network, and a long 100 kilometers long three-phase 50H transmission line has following line constants, and the resistance per phase per kilometer here given here is 0.1 ohms, and the reactance per phase per kilometer is given as 0.5 ohms, and the susceptance per phase per kilometer is given like this. See here the line supplied load is given as, that is the power is given as 20 megawatts at 0.9 power factor. See here power is given as 20 megawatts here given in the data, 20 megawatts, and what else here given, the receiving end power factor is given as cos pi r is given as, cos pi r is given as, that is equals to how much here given, that is equals to 0.9 power factor here given you. Okay. Now the lagging at 66 kV at the receiving end, that is the line voltage here given you as VL is equals to 66 kV. They had given you 66 kV, means 66 into 10 to the 10 cube, we can say 66 into 10 cube volts. We can say that it is a, this is the volts they have given, and the R resistance, reactance, and susceptance is given in this fashion. Now see here the total resistance, if at all I want to find, what I have to do, the total resistance I have to find, total resistance I have to find. See, the total resistance is multiplied with that of the total length of the line. Here the length of the line is given as, how much they are given, 100 kilometers long, three-phase 50H transmission line they are given. So the total resistance would be, what about the total resistance? The total resistance would be 0.1 into, what is the resistance he had given you? Resistance he had given you is 0.1. But the total length of the line is 100 kilometers. So I have multiplied this with 0.1 into 0.1 into 100. 0.1 into 100. So that I'll be getting R as 10 ohms. How much I have got? 10 ohms. This is nothing but the R I can say. This is the R ohms. I mean 10 ohms, which is nothing but R we can say. This is R. Okay. Now coming to the total reactance per phase. This is the reactance we have to calculate. What is the reactance he had given you? He had given you straight away the value, the total reactance, which is nothing but XL. What is it? XL is equals to, see the difference between the different sums, different problems, what we are doing now, there is a slight difference in the data. According to the data, we have to calculate the or derived what we want to determine. Okay, what we want to determine. Here they asked you to find the sending end power factor. That means what he has asked you, cos phi s he has asked you. What he had asked you, sending end side power factor he had asked you. What else he had asked you? He had asked you to find the percentage voltage regulation. Percentage voltage regulation he has asked you. What else he had asked you to find? Transmission efficiency he had asked you to find. These three you have to find. These three you have to find. What you have to find? Sending end power factor and regulation and transmission efficiency you need to find. For that, what is the given data you have to put? What is the given data over here? The given data is P is equals to output power is 20 megawatts. Receiving end power factor here given. Don't confuse whatever the is in the given data. He had given you the receiving end power factor. He asked you to find the sending end power factor. So all of you see this carefully. He had given you the receiving end side power factor, which is nothing but the 0.9. And line voltage is 66 into 10 cube. 66 into 10 cube volts. And the total resistance is equals to this 0.1. Whatever the resistance he had given, that resistance into total length of the line you have to do. Total length of the line, which is nothing but 100 kilometers length of the line. So that you will be getting the total resistance in that particular 100 kilometer length of the line. Now we are having the reactance. Reactance is how much they have given you? 0.5. 0.5 into 100 you have to do. 0.5 into 100. 0.5 into 100, which is nothing but how much it is? How much it is? It is of 50 ohms. Now in our hands we are having resistance and reactance in our hands. Now susceptance per phase we need to find. These are the per phase values. Susceptance. Susceptance per phase is equals to, see here, this is the reactive part. Every time why we are saying it is a susceptance? Any one of you, can you tell? See, in the reactance, Y is equals to G plus JB would be there. G plus JB. Y is equals to G plus JB. J into B. This is the reactive part which is there in the admittance, and this is the real part. As well, in Z is equals to R plus JX we are having, right? Z is equals to R plus JX we can say. R plus J into XL we can say. This is called as the resistance real part, and this is called as the reactive part, which is nothing but the XL we used to say, right? In the same way, in the case of Y, this is the real part, conductance. This is the reactive part, which is nothing but the susceptance. They have given you the susceptance value. That means in the Y, they have given you the real part. Okay. Now Y is equals to how much? How much he had given you? 10 into 10 to the power of minus 6. 10 to the power of minus 6 into 100. Into 100. How much it is? Any one of you, can you tell? 10 into 10 to the power of minus 4. Can we write like this? 10 into 10 to the power of minus 4. Remember, every time you have to multiply the data, given data, with the total length of the line, so that we will be getting the total resistance per phase value, total reactance per phase value, and total susceptance per phase value we will be getting. We will be getting the total resistance, total reactance, and so total susceptance values. See, here we are having three values in our hands. What are there? This total resistance we are having as 10 ohms. Total reactance we are having this. Susceptance, C part we are having as 10 into 10 to the power of minus 4 Siemens we are having in our hands. Here we are having cos phi r value is 0.9, and he had given you the sign, P as 20 megawatts and VL as this much. Now what we have to find? We have to find the load current. We have to find the load current. These problems are very, very important. All of you be concentrated and try to do the problems simultaneously so that you can understand better. See, the receiving end voltage per phase. The receiving end voltage per phase it is. The receiving end voltage per phase. So, if at all we do this, what is this receiving end voltage per phase? The receiving end voltage we are having at line voltage we are having at VL is equals to VL by root 3. VL is equals to how much we are having? 66 into 10 cube we are having. So, we have to root by root 3, so that this is nothing but into it is. See here, this is into, so that what it happens? It is equal to, it is a, now we have to equate it with this, and we have to substitute the values of that. What we will be getting, we will see now. See, VL is how much they are given you? VL is equals to, they are given you 66 into 10 cube. 66 into 10 cube they are given. Into 10 cube. This is 10 cube by root 3. How much is this value? Any one of you, can you tell? Can you tell?
38,105.11, ma'am.
Very good. 38,105. 38,105 volts I can say. Okay. Now, what is the load current? Can we calculate the load current? How can you denote the load current? Load current is denoted as IR. Why? Because it is there in the receiving end side, which is load is connected to the receiving end side. Across the receiving end we are connected. See here, this is the receiving end. Load current we can say. Load current is equals to IR current, which is equal to which is equal to, what is the formula? I'll be straight away putting it, root 3 VL cos phi, VL cos phi r, cos phi r it is. Okay, now cos phi r it is. This is root 3. If I put 3 over here, VL by root 3 will come. So what will becomes? It will become the phase value. Root 3 gets cancelled. So that I'll be remain this only. Now finally, this is equals to, how much is this? 20 megawatts they had given you. 20 into 10 to the power of 6. 20 into 10 to the power of 6 by root 3 into how much is this? VL, how much you had given? 66 into 10 cube. 66 into 10 cube into 10 cube. That into cos phi is how much he had given? He had not given 0.8. Here he had given you as 0.9. All of you make a note of it. Here the power factor cos phi r he had given you as 0.9. Okay. Now it is given as 195. It is given, see, it is a 195 amps. Have you got this value? All of you? 195. Have you got? Students, have you got after simplifying this?
Checking, ma'am. Wait.
Okay. 195 amps. Now, okay, you'll get, all of you try for it. Now, cos phi r is equals to, see here, cos phi r is equals to how much they are given you? 0.9. What is sin phi r? Meanwhile, calculate. What is sin phi r? Calculate. Sin phi r. See how to calculate this?
0.6, ma'am.
No, see 0.435 you'll be getting. Check it once. If it is 0.8, you will be getting 0.6. But here you are given you as 0.9. Have you got this value 0.4535?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah. Yeah. Point, it is, if it is given as 0.8, you will be getting sin phi r as 0.6. But here, yeah, here he had given you as, how much he had given you? He had given you as 0.9. So sin phi r is equals to 0.435 you will be getting. Okay. Now let us calculate one by one. If VR is taken as reference, the general steps what we are doing in each and every of the problem is same. Only slight difference is there, so that will makes a difference of the problem. That will makes a difference of the problem. According to the given data, you have to make a calculation. Okay, 105 you will be having, 105 volts you will be having. Okay, this is nothing but VR. Now, how to calculate IR, receiving and current? IR, we know the
into
IR into
sin 0.9 into
cos phi r minus j sin phi r. Okay, ma'am. Okay, ma'am, mute your microphone, please. Some disturbance. When I ask, you can. Okay, thank you. Sin phi r. Okay, sin phi r value, sin phi r, that is equals to 195. Okay, this IR what we have got, IR is nothing but the 195. Very good. Into cos phi r is 0.9 minus j into 0.435. 435 we are having, right? Simplify this and tell me the answer, any one of you. Simplify this. You will be getting, or else you check it once whether you are getting this one. 176 minus J85. J85 you will be getting. Okay.
Yes, ma'am.
Yeah. Now you will be getting this as this one. Now you have got the magnitude, real part as well as the reactive part. This is the magnitude of IR what we have calculated here, the magnitude. Here the angle will be there. That is, we will be getting the real and the reactive part this much. Okay. Now see here in the nominal pi method, we will be having the two capacitive currents. What are those? IC1. First of all, we have to calculate the first IC1 is equals to VR into J into Y by 2. J into Y by 2 you have to calculate. What is the TR? IC1 is bar, it is. What is the DR value? 38105. 38105. 38105 will be having into J into how much is Y we are having after multiplying with the total length of the line. It is 10 into 10 to the power of minus 4 by 2. Y to Y, it is of C by 2. So that Y by 2 we are doing. How much it is? See, it is of J19. It is the reactive part we are having. That is nothing but the susceptance what we are having. In Y is equals to G plus JB, the GB we are having. This is conductance. G is nothing but the conductance. B is nothing but the susceptance. Every time we are having this value we are getting. So see here we are getting the J19 we are getting. Oh, this is nothing but, that is why in the data he had given you the susceptance value. That means it is nothing but the B value, the reactive value which they are giving. Okay. Okay. Now this is how you need to find the IC1. Now let us calculate what else we need to find. The line current you have to find. The line current. What is line current? Line current is equals to, what is the formula for it? IR, load current plus the current passing through this capacitor which is placed near to that of the receiving end side, which is nothing but IC1. We know we have seen the figure many times. All of you recall that figure, so that this is IL is equals to IR plus IC1. IR plus IC1. See here they will be having like this. We'll be having like this, and we'll be having capacitance is this one, and here also we are having the capacitances. And let us suppose this is IL current, and here we are having the sending end voltage VS. VS is the sending end voltage, is it not? Now this is the load across which we are having the load we are having, which is nothing but this is the load we are having, and this is VR we are having. You can write freely, you can write all these things we have read many times. This is nothing but the IC1 current made to flow. This is nothing but the IC1, IC1. This is nothing but Y by 2. This is nothing but Y by 2. This is IC1, and this is IR current, load current we can say. This is the load current. This is IL. Same current is going to this line. IL is equals to IR plus IC1. That's what I have written here. This is nothing but IC2. IC2 is the current made to flow. This is nothing but the IS. Sending end current IS. Okay. Sending end side we are having a current of IS. Now this is the capacitance we are having. The voltage VS is applied. This is how the figure, this is Z we are having, the total Z R plus JXL. Okay. From this, what is IL? IL is equals to IC1 plus IR we can say. That's what I have written over here. So IR is equals to how much we have got? IR is equals to 176. Just now we have derived. 176 minus J85 plus what is IC1 we are having? IC1 just now we have calculated J19. Okay. Okay. Now finally you will be getting the value of 176 minus J 66.
6, ma'am.
Yeah, 66 you are having. Now, what else we need to find? See, this part we have calculated VR, IR we have calculated, IC1 we have calculated, IL we have calculated. What else? Z we know, R we know, XL we know. We have to calculate. What else we have to calculate? See, this is the part we have to calculate it for VS. VS. For knowing the VS, we need to know the VR plus IR into Z. VR plus IL into Z, we can say IL into Z. For this entire loop, the sending end current is equals to the drop plus this voltage, VR plus IL into Z. Now, what it would be? VR is equals to how much we are having? 38,105 plus 176 minus J66. J66. See, this is the IL value. This is the IL value I have substituted. This is the IL value I have substituted. IL is this. What is Z? Z is how much we have. We know that R plus JXL. R is 10. XL is 50. We have got. XL is 50. We have got. Just now we have done this one. See this one. This is the XL. R is how much? This 10. I have kept. XL is how much? 50. I have kept. That's what. That is the thing I have kept there. So these on simplification, what you will be getting? These on simplification you will be getting as 3838105. Boys, any one of you, can you tell the answer? Plus 5060 plus J 8140. These on further simplification you will be getting as, see, the real part and reactive part will be like this: 43165. For one calci to other calci, there is a small digit changes. No worry, no issue. The answer, if at all you get the near values with a slight change, it doesn't matter.
Correct
Okay?
only, ma'am.
Yeah. 43925 polar form. 925 at an angle of 10.65 you'll be getting. What is the angle you are getting? 10.65. Yeah. Now, this is the Vs whatever we are having. If suppose the charging current IC2 you have to calculate. IC2 you have to calculate. What is IC2? IC2. Vs into J into Y by 2. See, in the case of IC1, we have kept VR into J into Y by 2. Why? IC1 is near to that of this receiving end side. IC2 is near to that of this. This is the Vs. Vs into Y into V is the current. I is equals to YV. So Vs into what is the voltage across this? This is nothing but there won't be any drop here at this place. So whatever the voltage is present here, that would be the voltage across this Vs into Jy by 2. Y by 2 you can say. So this is nothing but Vs into Y by 2. Vs is this one. What is this? This value, all of you please put this value. Vs into Y by 2 value is how much? Into J 10 into 10 to the power of minus 4, 10 into 10 to the power of minus 4 by 2, minus 4 by 2 you will be getting. How much is this? Minus 4.0. See, all of you check it for this. Minus 4.0 plus J 21.6 you will be getting. 21.6 you will be getting. This is the IC2 value. Once after knowing the IC2 value, see here, from this we know the value of Vs and IC2 value also we have found. See, Vs we have found and IC2 also we have got. See, this is Vs value and IC2 value also we know. Now what else is the remaining? Only Is is the remaining. Let us calculate that also. Is equals to what is it? Is is equals to, what is the formula for this? Line current plus IC2. Line current plus IC2. What is the line current value we have obtained? 176 minus J66 plus minus 4.0 plus 21.6 J 21.6 you'll be getting, right? 21.6. Now you'll be getting the answer as all of you
172, ma'am.
172. Very good.
Minus 40 J 44.4.
Very good. 44.4. 44.4. Now that is equals to in polar form. In polar form 177.6 into what we are getting. Any one of you, can you tell what is the angle of it? 14.5, is it not? 14.5. This is 14.5 we are getting. Now, see, this is the sending end voltage we know, receiving end voltage we know. See, he had asked you to find the power factor. How to find the power factor? Let us see. All of you remember the phasor diagram what we have drawn? The phasor diagram. See, in that phasor diagram, VR is taken as reference. I just draw the angles in it. See, now here we are having the sending end side current is like this. VR lags IR and VR also IR lags VR by an angle phi. IR will be there. But here this is the IS is the sending end side current. Between this is the sending end voltage. If you look the phasor diagram, you can understand better. This is the sending end voltage we are having. IL is the load current we are having like this. This is the IR current. IR lags VR. This is the one. And the angle made by this IS and VR is nothing but, let us suppose this is theta 2 and this is theta 1 and this is nothing but the theta 1, and between IS and VS what is it? What is it called? It is nothing but theta S, we can say. Between IS and VS it is of theta S. If we apply cos theta S, cos of theta S, we'll be getting that sending end power factor. He asked you to find power factor at the sending end side. So we need to know the angle between the sending end voltage and the sending end current. If at all we know these two angles, see angle between the sending end voltage and the sending end current, then we'll be able to find the cos phi. See, reference theta is the angle, theta 1 is the angle between VR and VS. Theta 1 is the angle between VR and VS, and theta 2 is the angle between VR and IS, and this is nothing but how much is this angle? Minus 14.5. This is the angle made with this is nothing but VR and IS. VR and IS is, this is the angle, 14.5 is the angle, and theta 2 is 14.5 and theta 1 is how much? That is nothing but VR and VS. VR and VS is nothing but 10.65 we have got. 10.65. If you add this, theta S is equals to how much you will be getting? Theta S is equals to both theta 1 plus theta 2. Theta 1 plus theta 2. Are you getting me, all of you? This is the theta 1 plus theta 2. What is theta 1? Theta 1 angle is how much?
10.65.
Theta 1. Yeah, 10.65. 65. Plus
14.5.
what is this angle?
14.
14.5. Yeah. Plus 14.5 degrees.
25.15, ma'am.
Yeah. How much it is?
25.15.
25.15. Okay. See, this is how. Now, sending end power factor is equals to cos phi s. Cos phi s. Cos phi s. That is equals to cos of How much it is? 25.15. Cos of 25.15, how much it gives you?
0.9, ma'am.
Yeah, 0.905.
905.
0.905 lagging. Why lagging? I'll tell you. Listen. See, if at all you straight away see the angles, what is power factor by definition? The voltage angle between the cosine angle between the voltage and current. The cosine angle between the voltage and current. What is the voltage angle we are having? 10.65 you are having. What is the angle you are having for this current we are having? Actually, it is of minus 14.5 we are having, right? How much is the angle we are having? See here, it is of angle between minus 14.5 we are having. Minus 14.5 here we are having. Cosine angle between voltage and current means this 10.565 minus of minus 14. If at all you put here instead of plus, if you put minus of minus also, you will be getting this angle itself. You can straight away without writing all these things, this vector diagram and all, if suppose in any competitive exam, they may be given you the sending end current and sending end voltage. They asked you to find the power factor. What you have to do is the cosine angle between the voltage and current. Voltage angle is 10.65 minus of minus, we are having this, which is nothing but, sorry, which is nothing but minus 14.5 we are having. So minus of minus gives you the this much of angle we are getting. So we can straight away put that cos of 25.15. Likewise, you have to say, if at all you see like this also, it doesn't matter. Okay, it doesn't make any difference. Okay, this is how you need to do the power factor, how to calculate the sending end side power factor. Now, what else they had asked you to find? What else they asked you to find? Percentage regulation. What else? Percentage voltage regulation they have asked you. Voltage regulation they have asked you. Why we have got the minus sign there? I lags V by an angle phi, so it's of minus sign. The angle between voltage and current, between voltage and current means difference. So voltage angle minus of minus, that angle we have to put, so that you will be getting the this one. You will be getting what? The power factor at the sending end side. You will be getting the sending end side power factor. Now let us calculate the voltage regulation. Sending end side minus receiving end voltage by receiving end voltage. See, this voltage regulation can be found in three ways. One is by, if you know the sending end voltage and receiving end voltage, straight away you can put the values like sending end voltage minus receiving end voltage by receiving end voltage into 100. But he asked you to find the voltage regulation at no load conditions. If that are they asked you means at that particular point of time IR becomes 0. Now we have to calculate that formula as VR dash, voltage at no load minus voltage at full load. To that of the full load we have to calculate. To that of the full load we have to calculate. Okay, that is also one method of doing the problem. Okay, now we know Vs and Vr. So straight away we'll put the values of Vs and Vr. What is Vs we are having? The magnitude of Vs is how much? If you see the magnitude of this, what is the magnitude of this one? Magnitude of this is 43925, right? This is the magnitude of this one, 43925. So straight away you put that value 43925 minus, what is the receiving end side voltage we are having? VL by root 3. After VL by root 3 we have done 66 into 10 cube by root 3 we have done. This one will be getting 105 by receiving side voltage 38 105. Okay, now into 100.
15.27, ma'am.
Yeah, into 100. Now you will be getting 15.27. 15.27 we will be getting. 15.27% you will be getting, right? Yeah. Now, once after finding the voltage regulation, we have to know the losses. Okay. Losses, what is, okay, we'll be getting the input power, sending end power, if at all you find also, you'll be getting this. What is the sending end power? See here, the power is nothing but 3 into Vs Is into cos phi. Output by input, output by output plus losses. How to find the losses we are having? Losses can we either by finding the input or by finding the losses we'll be getting the answer. See, if I find the input, P is equals to, what is the input power? P is equals to 3 into Vs, Vs, Is. One problem can be solved in many ways. Okay, whichever you feel easy, you can do in that manner. Whichever you feel easy. Okay, 3 into Vs into Is cos phi s. Now 3 into, what is Vs value? 43925, we know. 43925 into what is Is we are having? 177.6. 177.6. What is cos phi s we are having? 0.905 we are having, right? 905. We are having calculated the cos phi s. So we know the input power. This is the input power. What is it? Input power is 21.8 into 21.8 megawatts, we can say. In terms of megawatts, we have converted. Why? Because the output power has been given in 20 megawatts. The output power has given as 20 megawatts. 20 megawatts. Or else 3 into IL square R losses also if you calculate. Losses if you calculate. Losses if you calculate. In previous problem we have done in this fashion. 3 into IL square or losses IL square R if at all we find. Now the efficiency can be written as output by output, as of now we know as 20. Output by output plus losses is one method of finding the efficiency. Output by output plus losses we can say. Now this is one method of finding after finding losses, and finding the input also is one method. If you know the input and output, can we find the efficiency? Efficiency is equals to output by input. Output by input, straight away we can put output by input, we can put. See, now into 100 if at all you do, this is nothing but, this is nothing.
91.74, ma'am.
Yeah. See here, 20 by 20 by 20 by 21.8. Do it once again, 21.8. It is around 94%. Check it once. Into 100. Now you'll be getting 94%. Check it once, please. It is not 91. It is
91, ma'am.
91 you have got, whatever it may be. Wait, I'll also check it. 20 divided by 21.8. Yeah, 91. Good. 91.74. 91.74 we are getting. Okay. This is how 91.74 we are getting. This is how we are finding the efficiency. This is how we are finding the efficiency. Okay. Now, this problem is completed. Now, let us see for the other problem. And this is the problem we have done. The same problem. Here it is 91.7. So, 91.7, right? 91.7%.
మీరు పవర్ కనుక్కున్నారు కదా మ్యామ్.
Yeah.
కరెంట్ మ్యామ్. అయ్యి ఒకసారి సెకండ్ స్లైడ్ తీరా మ్యామ్. మీరు చేసిన దాంట్లో మ్యామ్.
Yeah. How much is?
ఇంకా ముందు మ్యామ్.
Okay.
కరెంట్ ఇంకా 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 ముందు స్లైడ్ మ్యామ్.
Yeah.
ఇంకా దీనికి ముందు స్లైడ్ మ్యామ్.
Yeah.
మ్యామ్ ఇక్కడ మీరు ఐఆర్ కనుక్కున్నారు కదా మ్యామ్.
Yeah.
లోడ్ కరెంట్ అక్కడ విఎల్ దగ్గర 66 into 10 క్యూబ్ వేసారు కదా మ్యామ్. దాని బదులు మనం 38105 కూడా వేయచ్చా మ్యామ్?
3810? I didn't get you.
ఇక్కడ విఎల్ ఇచ్చారు కదా మ్యామ్, p/√3 VL cos phi r.
Where p by root 3
p/√3
yeah.
instead of 66 into 10 cube, we can write 38105, ma'am.
Yeah, when you'll write, that is the difference, Amma. I'm telling all of you, please be clear. Very good answer, good question. See here, if at all you put 3 into VL by root 3, if at all you done. See, if you do like this, root 3, then you'll be getting 36 point something else you'll be getting, right? Cos phi r. Yeah, cos phi r. See here,
336 ఎంత వచ్చింది మ్యామ్ నాకు అలా చేస్తే?
don't put this value. If at all you put root 3, if at all you put straight away, you have to do like this only. That's what I am telling. Please listen to me carefully and get cleared. If at all you put like this, then you have to do by root 3. This will be nothing but the phase value. P phase is equals to VL by root 3. If you put straight away, see here, this is, what is this value called? This is called as the phase value. Listen to me carefully, Amma. This is the phase value, right? VL by root 3 is the phase value. You have to put, when you have to put the phase value, if suppose if you have to put the phase value 3 into phase value is wrong. Understood? If you put root 3 into phase value, if you put, it is wrong. If you put phase value, it is wrong. Why? Because see here, you have to remove that root 3. Root 3 gets cancels, and you will be remaining with root 3 into the line voltage itself. You have to multiply, not the phase value. If you put root 3 at the front, you have to put the line value itself. You will be getting this value. If at all you want to put 3 into VL by root 3 into cos phi, if you do, then it is correct. Understood what I am saying?
ఓకే మ్యామ్.
Yeah, 3 into VL by root 3 into cos phi, if you do, it is correct. But root 3, if at all you put over here, it is VL only, not V phase. Line voltage only you have to multiply. You have to multiply the line voltage only. If you multiply the phase value, your answer will be wrong. See, why? Because P in terms of 3 phase, 3 P is equals to 3 into VL cos phi. 3 into VL cos phi r is the formula. Okay, 3 into VL IL cos phi is the formula. I we are finding. So I is taken on the left hand side, P by 3 into V into cos phi r. So 1 root 3 gets cancels, and we'll be remaining with root 3 into the line voltage only. This is the line voltage only. If you do it by root 3, then it would be the phase value. If you put at the front root 3, if you put at the front, then you have to put the line value itself. I hope you all clear. Okay, ma? Yeah. This is how you have to do the problem. This is how you need to do the problem. It is of 91.74 is the answer, which is nothing but the efficiency. Let me explain the next problem so that we can do that problem in the next class. Now time won't be sufficient, I think so. Yeah. See here, he had given you very good question. It is this type of models also they have been asked. They'll be going to ask you. It's very, very important in terms of ABCD constants, generalized circuit constants. See, we are doing the nominal T method, nominal pi method, or short transmission lines in both the ABCD parameters and the generalized method we are finding. ABCD parameters we are finding for any nominal T and nominal pi method in when modeling this network. Okay, now they have been asking you to find the ABCD constants of the line, sending end voltage and regulation of the line. See, the question is a balanced three-phase load of 30 megawatts. The power he had given you as 30 megawatts. All of you try for it for tomorrow's class. We'll start this, we'll do this problem in tomorrow's class. All of you try this problem, which is very, very important. A balanced three-phase load of 30 megawatts is supplied at 132 kV. Supplied at 132 kV means this is the line voltage we are having, 50 hertz, and the cos phi r is given as 0.8 power factor, lagging by means of a transmission line we are having. See here, by means of a transmission line. the series impedance of the line conductance is this much. That is R he had given and X also he had given you straight away. We need not multiply with the total length of the line and all that. He had given you the Z. What the Z he had given you? Z is equals to how much he had given you? 20 plus J 52 he had given you. All of you try this problem at home. Listen to me first. Try this problem and come for tomorrow's class. Now, and the total phase neutral admittance is admittance he had given you. That means this value is nothing but y he had given you as y is equals to 315. Again, he had given you the susceptance value. That means the B value here, G plus JB in that B value is here 10 to the power of minus 6 Siemens we are having. Siemens using nominal T method it is asking. What is it called? It is the T network. It is the T network. Determine ABCD parameter constants and sending end voltage Vs you have to find and regulation you have to find. Percentage voltage regulation. If once we know all this, we can find the efficiency also. ABCD parameter constants he had asked you to find. See, now how to find the ABCD parameters we have. So, we have the value of Z, we have the value of Y. We know the ABCD parameters for the nominal pi method. What is A? A value is 1 plus YZ by 2 and B value is Z into 1 plus YZ by 4 and C value is Y and D value is equal to A, that is 1 plus YZ by 2. We have derived ABCD parameters. In substituting these values y and z values in that ABCD parameters, you'll be getting the ABCD parameters. And cos pi r he had given you and same remaining all is same. We have to take the VR as the reference. IR lags V by an angle phi and we have to see this. We have to compare this equation with this. What is equation? Vs is equals to A into VR plus B into IR. In the same way, IS is equals to A into VR plus B, C into VR plus D into IR. We have to compare these two equations and we have to find the remaining things. All of you get prepared and all of you please try to do this problem. And in tomorrow's class, I'll be going to clarify this problem and I will going to tell you and explain you in clear about this problem. Today I have discussed this problem in brief. Please try it, all of you. Please try it. See here, IS is equals to C into VR plus D into IR. VS is equals to A into VR plus B into IR. We have to compare these two equations. Why? Because we are finding the ABCD constants, generalized circuit constants in this by using the data given. By using the data given, we have a Z value, we have Y value, we have power, we have line voltage, we have frequency, we have power factor. Okay, at the receiving side. Can we find this all these things, sending end voltage and regulation ABCD parameters? Yes, we can find by using this data given, All of you try to prepare try to solve this problem for tomorrow's class. In the next session, I'll be going to explain you this in detail so that you can please try the problem so that you'll be getting how to do the problems. So that you'll be aware of how to do the problems. Anyhow, we'll be discussing these problems in the next class. Anyhow, we'll be discussing this and one more problem we'll be discussing so that we can complete the complete second unit we have completed. And the next class, I'll be going to start you the long transmission line network, which is very, very important. All are important and easy, this subject is very, very important for competitive examinations. Very, very, as an electrical engineering student, this power systems is a backbone to is one of the very important subjects. So all of you please try to understand the concept. We have done so many problems in nominal T method and nominal pi method. What I have discussed just now, this is nothing but the nominal pi method, T method network in ABCD parameters, ABCD constants. We can do for nominal T method as well as for the nominal pi method also this by using this data. So all of you please try to do this problem. I'll solve in the next class. Along with this, we'll do some more problems. Okay, students? Okay, you can, those who are having any doubts, you can ask me or else you can leave the class. You can leave the class and go and join for the next session.
Okay, ma'am. Thank you, ma'am.
Yeah, if at all anyone is having any doubt, you can ask me now. You can ask me. If you don't have any doubts, then,